Hello everyone. So previously we had discussed on the topic designing a URL shortener, right? Similar to the BITLY, right? So BIT.ly basically. Yep. So yep. Today we'll be discussing on the topic, or today we'll be designing unique ID generator service. Yeah. So let's see what the question states here, right? So design a service that generates globally unique time sortable IDs in a thread safe manner, right? In a thread safe manner. So this is very important without relying on any external database. Yeah. So the service should support high throughput concurrent requests and provide a simple demo of ID generation. Yep. So this is the question. Simple one. Yep. All we have to design a service generates actually globally unique time sortable IDs in a thread safe manner, right? So this is fine. Now let's collect the this one, or yeah, let's collect the requirements as this one requirements, nothing but functional as well as the non-functional requirements, and then we can just move on with the other things, right? First, let's go with the functional as well as the non-functional requirements here. So here, what are the functional requirements? So generate globally unique IDs. So this is important. Yeah, generate globally unique IDs. Next, IDs should be sortable. Sortable based on what? Based on creation time. Based on the creation time. So this is fine. Support concurrent ID generation. It has to support concurrent ID generation as well. We have to keep this in mind. Next, demo with a external DB. Right. So this is fine, I believe. So this is fine. Yeah. Support concurrent ID generation. So this is fine. Demo with. So this is not with actually. Without external DB. Yep. So this is fine, I believe. We are just going with a LLD. This one, right? So let's go with a single file actually without the external this one database. Yep. Now let's go with the non-functional requirement here. High throughput and low latency. We have to keep this in mind. Thread safe. It has to be thread safe and collision free in memory generation. If it has to be thread safe and collision free in memory generation. Yeah, this one we have to keep in mind as well. The third one is minimal memory footprint. Minimal memory footprint, right? So this one is fine. The final one is easily testable and extendable. It has to be easily testable and extendable, right? So this is fine, I believe. Yep. Now let's move on with the this one. What do we call algorithm choice? Yeah. What's the best algorithm here? Basically, I found this algorithm best actually, best suited for this particular this one to write the code. Yeah. So we will be making use of simplified version of Twitter's snowflake algorithm. Yeah. So we will be making use of the simplified version of Twitter's snowflake algorithm. Yep. So what we'll be doing here, basically, so this is nothing but the ID equivalent to the timestamp plus machine ID plus the sequence number. Yeah. So this is what we'll be going with, and this basically ensures uniqueness as well as the sortable IDs. So this is one of the requirement, right? Sortable IDs without external database. Yep. So next, let's discuss about the concurrency as well as the data model discussion. When I say concurrency and the data model discussion, so we will be making use of the threading. Yeah, we will use threading. So we'll be going with a threading.log just to ensure sequence increments are just atomic. Yeah, so this one we have to keep in mind. Next one, keep machine ID fixed for demo. Keep machine ID fixed for demo. Sequence resets every millisecond. Yeah, sequence resets every millisecond. So this is also fine. So the third one here, this one data model actually. Data model. So ID is 64-bit integer, right? ID is 64-bit integer in the sense this one ID, whatever the ID that's generated, that is 64-bit integer. So timestamp, so this one 41-bit, machine ID 10 bits, as well as the this one sequence 12 bits. Yeah, this is fine, I believe. Now let's move on with the, this one UML diagram here. First one, this is the main class, nothing but the unique ID generator, which consists of the machine ID, which is of type integer, sequence, which is of the type int. Again, the last timestamp, which is of the type int, and the lock threading, this one lock, nothing but the threading dot lock, right, as discussed. So get ID, so we'll be going with the helper method get ID here, so which consists of the current millisecond, nothing but which is of the type int, and then we will be going with a this one as well. What do we call wait next millisecond? Nothing but last ts, which is of the type int, and we are this is nothing but the int and int. Yep, if you can't see. So this is fine, man. So the relationship is none here because we are going with a standalone service, right? So this is fine. This is fine. Now, this is fine. Let's do one thing. As we have discussed the UML diagram, then let's do one thing. Let's quickly write the code and discuss the code, right? Whatever the code that we have written along with the output discussion as well. Yep. So just give me a second here. First, let's do one thing. I'll just import here threading actually. Yep. So this is not showing. Yep. Import threading. Also, let's import the time as well. Yep. So this is also fine. The next thing is let's go with a class unique ID generator. Yeah. Unique ID generator. Yep. So this is also fine. The first part is here init, right? So let me go with init here. Nothing but the constructor part, initialization part of the constructor part here. Along with the self, let me go with machine ID here, machine ID, and set this one to initially 1. Yep, so this is also fine. The next part would be, let me go with, this is not showing. So let me type this one entirely. Machine ID equals machine ID, or let me go with a logical AND here along with. So this one, 0 x 3 double F actually. Yep. So what is this basically? We are just making use of 10 bits for the machine ID, right? So don't get confused here. Yep. So next, let me go with this one sequence actually. Sequence, let me initialize this one to the 0. Also, let me go with the last timestamp here. Yep. Let me initialize this one to the -1. And the final one here would be lock actually. Fine. Let me go with threading dot lock as discussed actually. Yep. So this is fine. Now we are done with the initialization part. First, let's move on with the current millisecond as discussed on the this one UML diagram, right? So first let's go with the current here millisecond, nothing but, and then I'll just go with self here. Yep. So within the helper method current millisecond, let's return here int of time dot time, so into 1000 actually. So this is fine. Next, let's move on with another helper method named wait next millisecond, right? So I'll just go with here wait next millisecond. Yep. So this is fine. I need one parameter here, nothing but the last as discussed, right? So this is fine. So within this helper method, let me set the ts to the self dot let me go with current millisecond. Yeah. So I'll just go with current millisecond. Yep. So let me make use of the parenthesis here. Let me go with a simple while loop. While ts less than or equal to last, this one, ts, then what shall we do? Let me set the ts to self dot here. Let me go with current millisecond. Yeah. So this is fine. Yep. Um, let me return ts here. So yep, I'll just go with return ts. Yep. So this is fine, man. Next, what shall we do? Next, what shall we do? Let's go with a helper method get ID. So we have to get the ID. So let's go with a helper method get ID. So we have discussed this one in the this one UML diagram, right? So we'll be going with the helper method get ID, the main one. So first, I'll just go with def here. Name of the helper method get ID. So let me go with self. And within the get ID helper method, so I'll just go with here self dot log. So this is also fine. And yep, the next one, let me assign ts2 self dot here current millisecond. Yep, so this is also fine. And let me write the simple if condition here, man. So if ts value of the ts, if it is equivalent to the this one last timestamp, right? So I have already written last timestamp. So let's include this one. So condition. So within the if, let's go with a sequence. This is not showing. Yeah, this is showing. Sequence, let's assign the sequence to the sequence plus one, or this one bitwise and 0x triple F that we have included here, right? We included, so we are going with a 12-bit sequence, right? For the this one sequence. How can I write this one? Just go with, let me write it on this way. So, sequence. We discussed this one already. We have discussed this one, right? 41 bits, 12 bits as well as the 10 bits, I believe. Yep. So this is 12 bits. For the sequence, actually, I have to go with plus one. This is fine. Bitwise, and I'll just go with a 0x here. Triple F, 12 bits. Yep. So this is fine. So the next part, let me write the simple if condition here again. Let's set the let's check whether a sequence is equivalent to the sequence value is equivalent to the zero actually. Yeah, if it is equivalent to the zero, then what we need to do, we have to assign the TS to wait next milliseconds of this one last timestamp, right? So I'll just go with a wait, this one, wait next milliseconds, this one, last timestamp. So where is this? So this is fine. Now let's go with the else here. Else what we will be doing, let's set the sequence to zero. Sequence to zero. So this is fine. The next part is last timestamp. So let me set the last timestamp to TS. So this is also fine. The next part is let me go with a unique ID. I'll just go with the unique ID. Let me set the unique ID 22. So this is fine. Or let me go with machine ID has to show. Yep, machine ID. This is 12 bits, right? So we are going with 22. Okay. Mm, yep. Or let me go with the sequence actually. Yep. So this is fine. Finally, what we need to return here, all we have to return is a unique ID actually. We need the unique ID, right? So this is fine, man. Yep. So this is it for the basically what do we call? This is it for the code actually. Simple one, right? So this is it for the code. Yep. Now let's do one thing. Uh, let me take the example usage from the Google Man. Just give me a second here. So this is fine. So I have just 1 second. So let me go with a simple explanation here. So this one generator, we are just calling the unique ID generator of machine ID. We are setting this one to the 42, right? ID equals 42. As we are going with the 41, this one, we have considered this. We have discussed this one already, right? So this is fine. Generating 5 unique IDs for this one, right? So this is fine. So, so basically, let me tell you here one thing. So each ID is 64-bit, this one, which is composed of one is timestamp, nothing but the 41 bits, and another one is machine ID, which consists of the 10 bits, 10 bits actually, and the sequence, which is of the 12 bits. We know this one, yeah. And there are sortable and unique. They are so this one IDs basically. When I say they are IDs are sortable and unique, even if generated in the same millisecond, yeah. So now we have the idea actually. This is it for the code. I have considered very simple example. Let's run the code. Let's see what output that we get here. So I'll just come here, Control J here, Python followed by the file name.py. Yep. See, we are getting none. 1 second. So actually, what's the mistake here? I think indentation actually. This one I have to move here, I believe. So this is out of this one. Let's do one thing. Hope this has to work now. I give clear screen. Still we are getting the same thing actually. 1 second. Let's do one thing. So this, if we are considering, right? So this one else has to be outside, I believe. So just let's do one thing. 1 second. So this one, let's move along with the actually else. So this is fine. Let me format the code once, and now let me run. Yeah, now we are getting the unique IDs actually. So that indentation was the problem actually. Indentation problem basically. Yep, so this is fine. We have successfully generated 5 unique IDs, right? So basically, we were considering this one, else for this if condition. So for this one, we are considering, right? Mainly line number 28. So this was the problem actually. Yep, so now we are getting the correct output or we are getting the desired output. Yeah, we have successfully generated 5 unique IDs here, right? So basically, each ID is 64 bit, which is composed of the timestamp 41 bits, a machine ID 10 bits, and sequence 12 bits. Yeah, IDs are sortable and unique, even if this one generated in the same millisecond. Yeah, this is fine, man. Now let's do one thing. Let's move on with the further things. So now we have discussed the coding part as well. We have successfully written the code as well. Yeah. Now we have successfully discussed this one. Output part as well. Now let's do one thing. Let's discuss the limitations of the code that we have written, and also the future discussions. Let's see. Let's first discuss the this one limitations of the code. So first thing here, this one, it's limited to the single machine demo, right? It is limited to the single machine demo. Sequence can handle only 4096 IDs per millisecond. Sequence can handle only 4096. This one, what do we call? Sequence can handle only 4096 IDs per millisecond. Yeah, so this is fine. Uh, Now it's this one tightly coupled to system clock, right? So clock rollback may cause collisions. We know this one. Yep. So this is also fine. And the final one is it's not persisted. Not persisted in the sense all IDs will be lost if the service restarts, right? So this is fine, man. Yep, now let's move on with the alternative algorithms that we can consider and the trade-offs, nothing but the summary. So we can just go with the UUID4, right? So when I say UUID4, this is simple. Collision probability very low. Collision probability is very low when we consider this one UUID4, and the only thing here would be it's not time sortable actually. This is not time sortable. That is the reason we didn't go with the UUI default. So this is fine. Next, let's move on with a centralized this one database auto increment, right? So this is persisted basically, but it can cause higher latency. So it can cause higher latency. So this is fine. Yep. So this is also one of the thing. The third one here would be this one. We can just go with the Zookeeper or Snowflake distributed variant, right? So this is fully distributed, but the setup will be complex here. The setup will be complex here, right? So basically UUID, it's known for the speed, and this one centralized DB, this one auto increment, database auto increment, nothing but the distributed. We are considering for the distributed systems. The final one is Zookeeper. This one, what do we call? Sorry, this one centralized DP. This is for the persistence actually, not distributed uniqueness. Third one, Zookeeper or the Snowflake. This one distributed variant. So this is for the distributed uniqueness. We can just consider this one alternative algorithms as well. So I found that one. The algorithm whatever we have used, that one is very relevant, and I just wanted to go with that all itself. Yeah, so that is the reason I went for that. It was simple and we don't have to make use of any external this one, right? External database and other stuff, as we are only discussing on this one LLD on solving the problem mainly, right? So this is purely we are solving the LLD problems basically. So this is fine. So this is it for the this one. This is it for the this particular question, right? So we have successfully designed this one. What do we call? Unique ID generator surveys, right? So I hope whatever we discussed is completely clear along with the coding part. Yep. For now, this is it. Thanks for watching, guys.